3 times the size, 4 times the size, why don't they feel noticeably better as a paradigm shift? The truth is, the breakthrough in 2017 was about architecture, was about the transformer. And the reality is that the transformer has a limit to how much you can squeeze out of it. And so we see this openly being discussed as there are natural ceilings to progress. And this is both a challenge, but for me as a computer scientist, it means that my job in innovation is fun again. And I think that this is what is interesting and what we think about as like what comes next. So what does that mean for what comes next? There's 3 areas I want to talk about, which is about where I think we should be focusing. The most important ingredient is that the next era of intelligence will be determined by the cost of adaptability, not by blindly scaling. And what does that mean? It's the cost of models actually working for everyday tasks. If you are smart and talented and you want to work at the edge of what is possible in computer science, I would say there's 3 main problems that are worth working on. The first, which is really adaptive data, is the idea that over time now, if we go to the next slide, we are in actually one of the most profound paradigm shifts. Most of computer science progress has been built on the idea of static data sets, expensive to collect, costly to maintain. And once you've collected it, you're done. You can't relabel it. It's very cumbersome. But for the first time, we have the ability to optimize in the data space, to make previously invisible worlds visible, to target parts of the data space that we don't cover. And this is actually profound because it enables more ownership of data, and it enables us to actually shift who owns the data. The second key problem, which I think is very important to talk about, is adaptive intelligence. So I have always led large teams in frontier AI labs, and the team that I'm leading now, this is the core of what we're working on. The idea is that we want to build models that are flexible, that adapt real time, that continue to learn from incoming data. And why this is important is that this avoids what people intuitively feel as attention, is that when you ship the same model to billions of people, you feel the strain of how it doesn't work for you. Everyone becomes an elevated prompt engineer. Everyone writes large scripts to try and wrangle what the data is and what it make it work for their use case. And the third thing, which I actually think is one of the most critical things, is that, and I think this is really about how we also shift that to much more gradient-free techniques. But the third thing that I think is very important here, if we go to the next slide, is that even the interface itself should be adaptable. Increasingly, we've been stuck with chat as our primary interface. But the truth is, I think most people intuitively understand that for AI to work in your everyday workflow, that also has to be flexible. That also has to suit. It can't just be text-heavy and essentially prompt-based. And so I think that this is one of our core focus, is how do we change the entire stack to be very flexible and to allow more people to have more control. I'm going to end with this. If we go to the next slide, I think that it's very clear that the future of machine learning is adaptive. This week, I was on panels with many of my fellow computer scientists, the researchers who have shaped this field. And what's interesting is that that is not the question. Most people accept that we have to move beyond these massive models. Most people accept that the transformer is dead and that we're not going to squeeze a lot out of it by throwing GPUs at it. But the question is, who will get us there? And I think for that, it has to be who focuses on sheer efficiency, who makes the cost of adaptability extremely low. And I would say that this makes scaling model size probably the least interesting solution available to us right now. And with that, I also want to say why that's personally very meaningful to me. So I think that efficiency typically means barriers to access are lower. And why this has massive implications is that it typically means more people can shape AI. If we think back to the original things I shared, most of what the hunger for GPUs has resulted in is concentration. Concentration who gets to build models, concentration who gets to shape the field, and it means that there's only a handful of researchers who know all the techniques required. And the focus on efficiency is also about the focus on who gets to shape it. And so this, for me, has driven a lot of my career. A lot of the work I've done has been in multilingual coverage, expanding access. But it's also what makes it fun and makes it the core challenge we have to do in the next stage. So with that, I would also say thank you, and thank you for an incredible week as well. So thank you so much. Yeah, excellent. Yeah, and I will pass over. I have a flight to catch, so I'm going to make a run. Yeah, very lovely. Thank you, everyone. Yeah, good luck with your session. Yeah.
Good evening, distinguished guests. Welcome to the session on powering AI. As AI scales at speed, so does its infrastructure demands. Data centers are facing unprecedented power and cooling requirements. A single large AI training run can consume as much electricity as thousands of homes use in a year. This raises critical questions like how do we plan for rapidly rising and uncertainty energy demand? Can edge computing reduce the load, or is centralization inevitable? To address these critical issues, we are joined by our exceptional panelists, Mr. Vineet Mittal, Chairman of Avada Group. Sir, I request you to please come on stage. Mr. Nathan Blom, Vice President, Cooling Chambers. Professor Raghav Chandra, Professor at IIM Calcutta, Founder and CEO of Consult, and former Chairman of NHAI, and Secretary to Government of India. Moderating this important conversation is Mr. Ashish Khanna, Director General of the International Solar Alliance. Thank you, panelists, for being here. With that, I now request Mr. Khanna to please take the discussion forward.
Good evening, everyone. Not easy being the last panel, especially when we are probably starting at the time that we were supposed to end, but we hope and we will try and make it more interesting for all of you. We are here to talk about powering AI. The format will be that I'll begin in terms of framing some of the issues at heart and also tell you a little bit about what International Solar Alliance is going to do. Then I will hand over to each of the esteemed panelists to make an opening kind of a statement of what's their vision on this question of powering AI for about 5 minutes each. And then I will ask them one question each on some of the specific issues for which they are probably an expert on. And finally, if there is any time left, we will see if any audience member wants to answer or ask a question. Let me start off by saying, why is International Solar Alliance in this session and in this AI Impact Summit? We are here primarily for two reasons. The first reason is the world has done 1,000 gigawatt of solar, doubled in just last 2 years, what was done in the last 25 years. Almost 40% of that is decentralized, which means it's either solar rooftop or pump or others. That figure is only 15 or 20% in India, and obviously very low in a lot of developing countries. And a distribution company often does not like decentralized solar because it impacts the distribution system and finances. But the right amount of digitization and AI can actually help them absorb it and reduce the cost of the system as a whole. And therefore, India's ability to more than double decentralized renewable energy, but in general world over, will require AI. That's issue number one, for which actually I will say that we launched a global AI mission for energy in the AI Impact Summit. We call it AI for Energy. The session is going to talk about energy for meeting AI demands, but let's first talk about AI for energy. Why? Because there are some elements that the world has not seen, which is, if some of you were part of some sessions earlier, can consumers trade power based on what rooftop and batteries do you have, P2P trading, that requires certain digital enablement of the trade of millions of prosumers, producers and consumers that right now needs a lot of regulatory involvement. An IT architecture so that each distribution company in India, but for that matter anywhere in the world, will know what will it make ready to actually trade that power. It's about jobs. Today, a lot of AI engineers do not understand energy. Energy engineers do not understand AI. We at International Solar Alliance, which is now 125 country member body, headquartered in India, is creating an ISA academy to train people to bring together AI and energy skills engineers together. This intersection of energy and AI will be the fundamental shift over the next 5 years, the way Amazon changed retail. This is what is going to happen, we believe, in renewable energy. Third is about innovation ecosystem. We are in the AI summit. A lot of startups are having fundamentally disruptive ideas on both decentralized renewable energy as well as way you manage generation, transmission, others. The fourth is about financing. How will all this financing, de-risking be done? Because not all places have a lot of venture capital or commercial loans and equity possible. And finally, there's a global dimension why International Solar Alliance is involved. What are going to be the interoperable standards? Because the world is not united on how all of this will be done. So that's a lot about AI for energy. But there's also an equally important element of energy for AI. The world's largest sources of increase in electricity consumption right now are only two: data centers and cooling. Some of it is going to happen through electrification of cars, EVs as well. Now, 70% of all data center demand today is US and China. But in times to come, as it's increasing by almost more than 15%, a lot of it is going to happen in developing countries. And we'll hear some of that in addition to global elements. A lot of that is also having a lot of innovation that will renewable energy provide that energy. Can 24/7 solar and storage provide cost competitive energy to some of these data centers, whether they're small or hyperscale being above 100 megawatt. What's happening on innovation on cooling? We will hear some of the experts on the private sector who are trying to come out with a lot of innovation on that and what it happens on the ecosystem. Obviously, today's data centers are consuming a grid equal to Spain right now, and it's going to double every 3 years. So this is a very important segment. Without further ado, I'm actually going to go probably to the esteemed panel. I'm going to request Mr. Raghav Chandra. Sir, you have been part of the government and now teaching. When you look at this big element of powering AI, how do you see?
Thank you, Ashish. You've done a fantastic job by, in a short time period, covering the larger macro issues connected with this sector. Friends, as we gather here in a nation racing towards digital sovereignty and sustainable growth, I want to emphasize, and putting on my academic professorial hat, the single greatest constraint on AI's future, which is not algorithms, not chips, but it is energy for AI-based data centers. And, I'm going to mention a few such instances. In late 2024, Mark Zuckerberg made a confession that stunned his employees. A nesting colony of bees had torpedoed Meta's plans to open the world's first nuclear-powered AI data center. That single environmental snag exposed their deeper vulnerability, that Meta's AI strategy depended on a single resource that it did not control and command, which is electricity. Power outages and energy shortages have increasingly disrupted major tech companies' operations, particularly as AI-driven data center demands strains global grids. There has been another very famous incident of March 29, 2025, a sudden loss of utility power in Google Cloud's Columbus, Ohio unit triggered a critical failure in the uninterruptible power supply UPS batteries that created a major havoc for several hours. This caused a cascading outage of 6 hours, in fact. Over 20 services were hit. Various customers experienced degraded performance or total unavailability, affecting cloud-dependent apps and websites globally. No direct apology was, of course, issued, but the event underscored energy reliability in a big way in an era of AI growth. In September 2019, utility power failed at one data center in Amazon Web Services, AWS's North Virginia zone. Backup generators activated but ran out of fuel after about an hour due to faulty automated refueling systems, exacerbating the blackout. And it affected about 7.5% of the volume of apps and databases, and some customers lost data permanently if backups weren't in place. Services like Slack and Netflix saw major ripples. And this has happened not only with Google Cloud or with Amazon AWS, but it has happened with companies such as Microsoft's Azure, which suffered a major setback in 2018. It has affected TikTok, that's ByteDance's new USDS joint venture, causing widespread system failures. And what it underscores is the need for ensuring that there is suitable energy availability for data centers and that there is suitable backup for data centers. Otherwise, you will not be able to have high-powered, energy-guzzling, AI-based data centers, which are the basic unit for AI to be implemented across the board for simplifying and for making and achieving our goals of ensuring that we have AI which is responsible, ethical, efficient, and which can do our job effectively. There is one county in the US which my friends here on the dais would be aware of, Loudoun County, Virginia, just outside Washington, D.C., where data centers now outnumber people in density. And this 40 square kilometer area of computer server farms is christened the data center capital of the world. It hosts about 200 operational facilities, and another 100 or so are coming up. Their peak draw is nearly 3 gigawatts. That's enough to power a small country. Over 70% of the global internet traffic passes this little area. What brought Loudoun and its implications to the world's notice was the massive outage at Amazon, causing tripping of crucial banking services and various social media companies. In Ireland, a data center already consumes their data centers consume already 1/5 of the nation's electricity, more than all the urban homes combined. Data centers traditionally began as largely in-house centers for proprietary computing data storage. They have since evolved, and today they are largely remote facilities or networks of facilities owned by cloud service providers, housing virtualized infrastructure for the shared use of multiple companies and customers. They need tons of electricity. With all the power-hungry hardware and cooling systems, a data center today uses higher density racks, and whereas earlier the data center typically used something like 150 to 300 watts of electricity per square foot, today these higher density racks can consume as much as 100 kilowatts per cabinet, which equates to 10,000 watts per square foot. And therefore, a data center power problem can have global ramifications for the company. AI is supercharging data center boom that will recharge global energy systems. Global data center electricity consumption today is 415 terawatt hours. That's about 1.5% of the world's total consumption of electricity. And by 2030, It's predicted to be nearly 945 terawatts, or 3% of the total consumption. So AI is not a side story. It's the main driver, with accelerated servers growing 30% annually in the United States, which is the current epicenter. Data centers use 176 terawatts in 2023, or 4.4% of the national electricity. Projections are staggering. That's like adding, in fact, the entire power demand of countries like Australia or Spain. So, when we look at powering AI, we have to look not just at the upstream issues of creating the requisite demand, of creating the requisite power supply, but the other factors which come into play are the downstream effects and the hidden costs of progress. Environmental. If we rely only on fossil fuels to bridge the gap, emissions soar. So you have the debate between thermal and between renewable, which my colleague here will talk about. Big tech's scope of scope 2 emissions are already up 30 to 50% since 2020. Globally, data centers could claim 40% of new fossil generation if clean supply lags. And so, while on the one hand, AI can help to accelerate decarbonization through optimal strategies and with intelligent working, but at the same time, the very fact that they are power guzzlers, they have an environmental issues which is inherent, and therefore there is a need for choosing a virtuous path. They have economic and social costs. While power prices are spiking, for instance, in the US, in and around areas which have data centers, the power cost has gone up significantly. In fact, wholesale electricity has jumped 200 to 250% in 5 years in certain areas, and the households are feeling that pinch. There is an issue of reliability. Grids weren't built for this. Voltage swings in Virginia have already tripped dozens of centers. In a warming world with rising AC loads, blackouts aren't theoretical. They're a governance failure waiting to happen. You have the equity issue. Who bears the burden? Communities near data centers face noise, heat, and land use conflicts. In developing nations such as India, the digital divide widens if energy access for AI crowds out basic needs. So there's a need for ingenuity when we're dealing with this issue, and efficiency has to be the best weapon for dealing with the larger social, environmental, and other issues connected with this. And of course, in India, a lot is happening about which we'll talk about, but there is indeed a moment of great happiness that AI is powering us, but there is also need to be concerned about whether we will be able to power AI effectively and whether we will be able to effectively and efficiently manage the downstream effects of powering that AI effectively. Thank you.
Thank you so much, Raghavji, for the different elements of sustainability risks for the society. Nathan, your opening statement, especially from the cooling perspective.
Thank you. So I'm going to come at this from a slightly different angle because this is a very complicated problem that we're trying to solve for. We can look at the fact that AI data centers especially are consuming a ton of power, and we need to generate more power, so it's a supply issue when it comes to power. But first, the question I think we need to address is, why are AI data centers becoming so power hungry? And I come out of the IT world myself, so this is the way my brain starts to think of it, is that when we get down into the core ecosystem or infrastructure of an AI data center, the AI data center today is very dependent upon the GPUs, the graphic processing units or accelerators that are allowing this massive jump in compute capacity in every generation. But what comes with massive jumps in compute capacity is equal to the massive jumps in the amount of power required to make those chips operate. And so basically all a chip is it's basically silicon, which is like sand on a beach or in the desert. And if you've ever walked on that, when there's sunlight shining on it, you know that it gets hot very fast. In fact, there's almost a 1-to-1 ratio in terms of the amount of power required to operate one of those GPUs and the amount of heat that you're generating as a result of that. And so what that implies is that every generation, which is about an 18 to 24-month life cycle, every generation from NVIDIA or from AMD is almost doubling in the amount of energy each chip consumes. And the number of chips that we're putting together in clusters is dramatically increasing too. It was a time not long ago in which a cluster of 50 or 100 GPUs was considered to be a neural network. Today we're talking about 5,000, 10,000 at a time. And when you start hooking them all together, that logarithmically increases the amount of energy that is required to make that AI data center operate. And so that's why we're suddenly talking about gigawatt level facilities, just single data centers that require just 1 gigawatt themselves. As a result of that, there are two things that I think we have to address in order to power the future of data centers. One is the effectiveness of our cooling technologies, and the second is the efficiency. And so the effectiveness is to what I was just saying. We have to have cooling technologies that are capable, that have the scientific and physical properties capable of capturing the heat that's going to be generated by next generation N+2 generation chips and rejecting it out of the building, so that we do what happens in IT, if you're not familiar with this, is that if the chip gets too hot, it throttles its performance down to the maximum that it can support at the heat load that it is at. So there's what we call a Goldilocks zone, not too hot, not too cold, that is designed for Intel or NVIDIA or AMD or Broadcom chips. And if they can stay in that, we can get the maximum, 100% performance out of that chip. But if it gets above that, the chip actually will reduce its performance down to 80% or 75%, which is counter to what we're trying to accomplish when we're building these new generation chips. And so we need an effective technologies in cooling that are able to capture that heat and reject it to the external atmosphere, or even capture that heat and reuse it for something better, like heating buildings or heating water or other things that require heat, or even creating generative power. So that's the first thing. And today's technologies that we're using originally have been air. We try to spin fans fast enough and cool the air low enough so that we can pull air across the surface area of these chips and capture the heat that way. And that's the legacy of what Northern Virginia, as an example, is built upon. Most of those, almost 95% of those data centers are air-cooled data centers, and they are incredibly inefficient. We use what's called a power utilization efficiency equation that says of every electron that's being consumed by a data center, how much is being used for compute and how much is being used for something other than compute, which is primarily cooling. It could also include the lights. It could include other, ancillary things, but primarily it's compute and cooling. And if you had a 1.0, that would be perfect. Every electron is going to compute. Everything above a 1.0 implies an inefficiency where cooling is taking up some envelope of what you have to produce in energy. And so the average globally data center operates somewhere around a 1.5 today. In places like southern India, where it's much hotter and more humid, you can be well over 2.0. And what that implies is that if I want to build a 100 megawatt data center, that is 100 megawatts of compute power, at minimum, I'm going to have to create 150 megawatts of power, or maybe even 200 megawatts of power. Incredibly inefficient. And so we need technologies that are both effective, that is, that they're capable of capturing this heat while still being efficient, that is, that they're not generating more need for power to trap that heat and reject it. And so what we're going to see across the entire ecosystem, from generation all the way down to the chip level IT, is innovation. We're going to see lots of innovation in the coming years in which we're going to figure out how to generate more power. We're going to figure out how these chips can become less power hungry per unit of compute that they're creating. We're going to see the capacity for the cooling technologies within the data center to advance to the point at which they're more effective and efficient. This is going to be a problem that everyone needs to solve. This isn't just one part of the ecosystem can solve this. And what I'll end with is the advantage that an emerging market like India has is that you don't have to repeat the mistakes that have been made by those who already have built out large ecosystems. It is incredibly expensive, and there's a ton of inertia that keeps these Northern Virginia, as an example, data centers from adapting to more efficient and effective technologies. But when you're starting with new builds, with white space technologies, you have the opportunity to actually build for the future instead of build for the past. And so that, to me, is the most important element as to how we're going to solve powering AI in the future.
Thank you, Nathan. I'm sure you educated a lot of us in terms of what's really happening on the cooling side, on the innovation. Vineet, over to you, that from one of the leading renewable energy developers, how do you see?
Yeah, good evening, everyone. So I see AI as one of the biggest opportunity for the renewable sector. Historically, people believe that renewable is intermittent, which it is. It is difficult to predict when the sun shines and wind blows. So we needed a technology which can help us intermittent power dispatchable at 15 minutes interval so that the grid can operate in a stable environment. So what AI has helped that with the help of lot of climatic data which weather department collects, company like renewable companies are collecting, defense department collects, and then you can get real-time data from low Earth orbit satellites. If you use all of them in the right way, you are able to predict using AI that what would be my generation like, and then you go a step further and you can schedule and dispatch that power like a conventional thermal power would do. So that makes AI for energy and energy for AI. And that empowers the grid to have always on clean power, which is the uniqueness India offers. So let me tell you, friends, when India started adding solar and wind some 15, 16 years ago, we didn't even had 5 megawatt of operational asset. And this year alone, India is going to add 50,000 megawatt of solar and wind capacity, making us the second largest green energy player besides China. And what it gives power to India is that, like the previous panelists were saying, in the US, in Malaysia, even in Ireland, which used to be the data center capital, every country has started charging some surcharge on powering the data center. But the reality of life is that there are not going to be 50 megawatt or 100 megawatt data center. Now we are talking about 500 megawatt gigawatt data center because the compute requires so much of heating, as Nathan has explained. Without impacting the society and affordably, if you have to do, India is the place. And the reason I say that we are blessed with abundance of sun, wind, and water. So using the pumped storage because of our geography, we are actually getting a natural ability to do storage. So, and largely in most of the states, sun and wind are complementary in nature. So what happens is using sun and wind alone, you can generate 14 to 18 hours of power, and then you complement it with the pumped storage and battery. And if you combine with the AI and you build your AI stack properly, you are looking for round-the-clock green power. So India is the perfect location. India is adding 50 gigawatt. It's not competing with normal consumer. India has a lot of very good policy where using green power, they are able to move even farming activity from the night shift to the day shift. So, and our per capita power consumption is one of the lowest in the world. We are less than 1500 kilowatt hour per year per capita. So if India has to become a Viksit Bharat, you can't become Viksit without data, and data is the new oil. And unfortunately, what is happening today is that we have 1.4 billion people, and out of which a billion people are connected, and we have one of the cheapest data connectivity package in the world. So we are the largest user of YouTube in the world. Almost 700 million user on the YouTube is from India, and we are the largest content creating economy, whether you take Insta, whether you take YouTube, you take any social media. It's a repeat story. Even on WhatsApp, we are more than 500 million user. And all of this data, as previous speaker was saying, resides in some other countries. So why should we generate so much of data and the data should reside in any other country? Because probably earlier we didn't focus to use all this abundance of energy and power that to data center. And now today, the scenario is it makes economic sense. In US, now you cannot get any power before 2030. All, even the gas machines are sold out. So if you look at the grid waiting time in the US is typically 7 to 8 years. Permitting, you can get during that time, but if the world has to adopt AI at a massive scale, India offers that opportunity where we can set up multiple gigawatt data center. We can provide them green power using solar, wind, and storage. And we are actually have a very unique situation. Unlike US or Europe, India has a single grid. You can insert the power in Rajasthan and can pick up in Mumbai in real-time basis, and India has invested heavily into the grid, and we continue to grow that national grid where the whole country is connected. So the best location for solar, best location for wind, best location for pumped storage and battery can bring power to the data centers in Mumbai, Chennai, which are already connected with multiple optical fiber. So the latency does not become the bottleneck, and it becomes the ideal choice. What is needed is probably more data sovereignty type of act, that the Indian user content has to be located in India by certain time frame, and so that developers can plan for the grid, they can plan for the large data center capacity, and can bring that to light. So it's one of the greatest opportunity for India. Indian ecosystem is purely geared up for that. And on top of that, we have, if you look at even in the AI, probably more than 25% of talent resides in India. And that talent currently is working for other countries, so they will be based in India, work for India, and provide services and intelligence to the rest of the world. And that's the way moving forward.
Okay, great. So let's have a little bit of a discussion, and I do hope we get time for one or two questions. So there was a little bit of caution that Raghavji you talked about, but a lot of optimism on both sides. I will ask a question combining two elements which are important. One of it relates to the whole policy and regulatory landscape. Is India, or for that matter, developing world's policy and regulatory landscape conducive for promoting data centers? I think Vineet, you talked about the importance of data, the policy and regulatory landscape related to data sovereignty. Even Africa, I remember, was thinking of having a legislation like Europe, where the data for that particular continent or that particular country should be within that region. But then there is also a policy and regulatory landscape for discovering price of power for data centers. India believes it's very competitive. US is struggling with the cost of providing power. Power probably is a limiting factor rather than the NVIDIA chips. So that's where the US is. The second element is on innovation. I think you spoke about it, Nathan, but we'd like to hear what would an innovation landscape for cooling look like? Is it a lot of startups? Is it a lot of some of the larger companies doing some process efficiency? What would this innovation landscape look like? I'm going to request each three of you to think about and say what would a policy and regulatory landscape change and an innovation landscape change accelerate both the speed and the cost of what meeting the demands of data centers look like. Raghuji.
So in the Indian context, you know, the stakes for us, as Vineet mentioned, with all the opportunity and the resources that are available to us in terms of land, in terms of water, in terms of the skilled manpower, the opportunities are enormous. And the data center capacity is all set to explode. Today, it consumes about 1 gigawatt of power today. We are expecting it to reach about 8 or 9 gigawatts by 2030. And it's continuously growing. We have ambitious states like Andhra Pradesh, which can effectively be called the data cities or data states for the country. We have a coal-dominated grid, which India has fortunately allowed to continue in a very pragmatic way. We have rising cooling needs from extreme heat. And as Nathan mentioned, that some of our states can have a power usage efficiency or effectiveness which can be extraordinarily high because of all the heat, whereas ideally it should be 1, which is the perfect index. And we also have a net zero ambition of ensuring that we have complete renewable focus, non-fossil fuel based energy dependency to reach by the year 2070, which is our global commitment, which is, I think, again, a very bold and generous commitment of India. But the biggest issue that I find in this entire landscape, if you ask me, is about the ease of doing business in India. And I'm not being skeptical, but having been an administrator who has been a managing director of the State Industrial Development Corporation, the State Investment Corporation, the managing director of the Road Corporation, the Urban Development Principal Secretary, Chairman of the National Highway Authority, and various other such positions. Now when I sit back and I'm on 6 company boards, I realize that the biggest bottleneck in India today is the lack of synergy between the states and the center, between the departments of the government and essentially between the states and the center. And if India has to move forward to achieve this huge target that it has set for itself for ensuring that we become the data center country for the world, that we exploit our entire human resources, that we exploit our land resources, the solar energy that we have, we must have, apart from the regulatory schemes, etc., and on the regulatory side, much is being done. For instance, in the latest budget, we are all aware that how the finance minister announced the scheme for ensuring tax exemption for data centers that are set up in India with foreign collaboration for the foreign component part of the investment and for their revenues. Lots happening on the renewable energy front. Lots happening on the various data centers that are being set up. However, lots needs to be done in terms of getting synchronized coordination, ensuring that the best technologies are brought in. One of the points which Nathan made was about leapfrogging and ensuring that India should capture technologies which other nations have faultily or by mistake adopted. We can certainly skip that and go on to the best technology. Water in the days to come is going to be a very, very big and critical issue for India. And therefore, using liquid coolants and solutions such as that for cooling are going to be extremely important. And this has to be realized not only by the central government, by the states, and by everybody who's working in the field, that they must facilitate ensuring that these things are adopted in a positive manner. I had an example of a foreign company which the other day was talking to me, and they had signed an MOU with a particular state government for a huge amount of data centers to be established there, and they said that, you know, we are struggling, we've made 8 presentations and we haven't been able to move forward on that. Now, that's the kind of thing which, with the best intentions and with our Prime Minister being so proactive, that we should really have proactive chief ministers, everyone getting down to business and using the large number of experts who are available all around to explain to them the best technology, and moving beyond perhaps even L1 to be able to get the best configurations on the ground to ensure that we are not only efficient, but we are effective.
Great. So a lot of potential, but work to be done on ease of doing business, center-state coordination, and also from innovation, a big potential for Indian companies to innovate on cooling, liquid cooling, especially given water constraints. Nathan, over to you.
Yeah, I'll comment on that innovation, because innovation is the foundation that the IT industry is built upon. And it's built upon the idea that any one individual or small group of individuals can create an idea that changes the entire multi-billion-dollar industry itself. And those who don't innovate end up falling off the map. You know, you don't talk anymore about AOL or Ask Jeeves or companies like that, and maybe we'll say the same thing about Meta or Microsoft or Google or Amazon someday, who knows, because that's the nature of the industry. And so as we look into the future, I think the innovation is going to require these smaller companies who are able to take risks and think bigger, especially around these cooling technologies. And that's what's already happening today, is we're seeing people who are thinking outside the box of what we've normally considered to be advanced cooling technologies. Today, when we talk about advanced cooling that's being deployed, what we're really talking about is moving from that air-cooled ecosystem to just a simple liquid cooling ecosystem, which was developed in the 1960s for the Apollo space mission in the United States by IBM. And it's been used for all of those years, including if you're a gamer at home, it's been used in those large desktop gaming systems. And so this is an old and proven technology. You basically use ethylene or propylene glycol mixed with water, and you pump it through a pipe, and it touches a cold plate on top of the hot chip, and it captures it in liquid and moves away. And that is a very simple and easy way of capturing heat, but it has limits. And what we're facing is the limit that liquid, as it leaves the chip, is getting so hot that you then have to have some coolant, some way to cool it back down. And that uses an incredible amount of electricity to cool that water back down, to use chillers on the roof of your data center to chill that water back down. And so the delta between the heated water, glycol, and the chilled water has to continue to get bigger and bigger and bigger, which means you have to cool that water lower and lower and lower using more electricity, so you eliminate the efficiency. There's now technologies emerging, and this is what my company is focused on, that is very similar to the way we cool air in an air conditioner or in your car or in your refrigerator, and it's called a two-phase technology. And basically what that means, instead of pumping liquid around and it staying liquid, the liquid boils and vaporizes, and that change of phase, that is from a liquid to a gas, is 10 to 20 times more effective and efficient at capturing heat. And that technology, though, is being spearheaded by small companies, and those small companies will get bought up by large companies, and they'll be adopted into the ecosystem. And so expect to see that. Expect to see the same basic use of refrigeration or refrigerants that we have today and we've been using for a long time, but using them specifically within the IT load of a data center ecosystem. That allows us to get those PUEs, that utilization efficiency ratio, not 1.5, but 1.05. You see that, that's a massive step function increase in efficiency, which means the power generation doesn't have to be strained nearly as much. And so I think that's where the innovation is really going to come in the next 3 to 5 years.
Great. I think on the lighter note, I'm always, it's baffled but amusing that the gaming industry was the start of GPU and now the cooling as well. It's
how NVIDIA
fascinating how
started,
gaming
was,
industry is responsible
gaming,
for the
yep.
AI revolution. But a lot of space for small companies if you have on the innovation side. Vineet, what do you think?
Gaming and BESS. Actually, because the large batteries requires the same amount of cooling. So the way I see innovation happening across the board is when the knowledge and the cross-industry expertise starts fertilizing. And for that to happen, you have to start creating a local ecosystem. See, we can't be sitting on the fence and be solving and innovating consistently. That you are doing in theory, but when you are building large data center of gigawatt scale, you can find solution and use those skills. Because the similar challenge comes when you design the clean room. So how do you combine the expertise of building a clean room of millions of square feet with the expertise which is required for cooling the batteries and the expertise which is required for power uses efficiency in the data center? How do you combine those skills and build the solution which is good for India, where the humidity in some of the cities where optical fibers are terminating through the sea is large, and how do you balance it out? So you have to use the external environmental data also to customize your PUE efficiency. So we see that efficiency is possible at all levels, whether the ceiling height should be 6 meters or 8 meters, how close to India. So India is, in that sense, is fortunate that we are building those expertise locally without building those 100 gigawatt of data center. In Morgan Stanley did a study. There is a $4 million opportunity cost for the power. So they are saying the battle for the AI is no more compute, and it's no more intelligence, it's the power. Power is the biggest challenge, and there is a lot of innovation which is happening on power sector in India. You gave a good example of P2P trading using AI. And the policy in India is quite open on open access. So when I give power to the grid and I'm taking it out, I'm getting the power in the real-time basis, which is very few countries are able to do globally, and we have to account for on the monthly basis. So that gives a flexibility to the data center, which always want clean power, and they want 24/7, 365 days reliable power. That is what is available in India. And I agree with Raghoji, ease of doing business is not similar across the states in the country, but that's why Government of India is doing stack ranking of the state. So today, you can't be just dependent on one state. Like, look at Maharashtra, the kind of support they are providing today. If you want to build data center is amazing, like permitting, land, everything is fairly streamlined, and on top of that, they incentivize. So I think government has got it, not every state is on the same page, that if you have to become a developed nation, data is the biggest enabler. If you have to win any kind of manufacturing battle, data is the biggest enabler. Like if you look at today, even our financial data, most of the software companies, whether it is Oracle or SAP or Microsoft, they want the data to be on the cloud. And those data, even your financial data, now even SAP, you can't do ECC, everything goes on HANA on Rise, which is on the cloud. So you buy the space either from AWS or Microsoft, because they have only partnership with those two. So even the 40,000 odd companies which are on these ERP softwares in India, where are their data going? And so the opportunity wise, I think India, because of its own need, will innovate consistently. Ease of doing business is a challenge, and that's where there is an opportunity to continuously work with the government on transparently on your challenges and suggesting a solution which is not benefiting one versus other. And then third is understanding the nuances of how the application layer is working across the industry, and educating government also that why should they have the data localization initiative. And I see all of this getting combined, and India becoming probably the third largest country where the AI adoption and data center would be one of the enabling block for the future growth.
Thank you. So a lot of optimism. I did promise one question. I have one question space only, so please go ahead. If you can identify yourself and have a brief question.
Well, my name is Umesh Prasad Singh, and I'm an associate member of Indian Institute of Public Administration. Sir, my question is directly to you. In your paper, you have mentioned about global ramifications. That particular aspect of global ramifications are of both types, that is positive and negative. With respect to that, will you just have the clarification on that note? I wanted to know on that.
So when I said global ramifications, I'm talking of both essentially the downstream effects of focusing on data centers and the implications it has on the fact that it will have an implication for the environment, because they are power guzzling, as Nathan mentioned, that today, earlier we had data centers which were full of CPUs. Today they are full of GPUs, and you're going into all kinds of even more complex computing units. So because of the storage, the networking, they are becoming far more complex. So it's going to have an impact on the environment because of the heat that is generated intrinsically because of the data center, because of the environment that will be affected, because when you're consuming coal to produce that power, you're using water, that same water which could feed millions of people and pay the, today we are not able to feed enough people for, provide adequate drinking water 24/7 to all our cities, yet you would have water effectively being used for the cooling of the data centers. You will have social issues, because people today already for thermal power plants, they are creating issues where they find that their land, especially in the scheduled areas, etc., is being consumed for coal mining. So there are issues connected with that. Likewise, there are all kinds of social and environmental issues that are likely to happen. There are issues on the side of, whether we, what other implications it can have. So all these are things which are not essentially just localized, though they are local problems, but they will affect global companies, which can have the benefit of India is that we can leapfrog in terms of technology. And hopefully, as one of the speakers earlier in the previous session mentioned, chips are also becoming more and more efficient. So, as they become, computing becomes more efficient, the chips become more efficient, so you will require a lesser amount of energy. If we can leapfrog, adopt the best technologies in terms of design and infrastructure, that again will be a great saving. So today, no nation is an island. Everyone is connected, and anything which impacts one nation affects the entire this thing, because data centers, if they are located here, as I mentioned the case of the Loudoun County outage, it affected billions of people all across. So it has a global ramification. While you have to think of your own benefit, you have to keep an eye also on the impact whatever you're doing has on all across the nations. And which is why when the Prime Minister talks of Manav, it is the human being who's at the center of it. And the human being is not just you, it is the larger mankind and the larger human community.
Thank you. Unfortunately, we do not have time for any more questions, but it's pretty late. I'm ending without summarizing, but it's pretty apparent, huge optimism on the power of India and developing countries to meet the demand for AI, both through solar storage, innovation on liquid cooling, and of course the ecosystem with ease of doing business. Please join me in giving a big round of applause to all of them. And thank you for staying very late. Thank you everyone for joining. Thank you.